Hey there, y'all. Today we're going to look at 1.3 on rate of change and slope. Our objective for this lesson is that you'll be able to find the rate of change and determine the slope of a line. In FIF 6, that's the standard we're looking at, we're going to determine the rate of change of a function over a specified interval and interpret the meaning of it in a given context. So a lot of what we're going to look at today is not just looking at a line and being like, oh, the slope is 3, but looking at word problems, application problems, and understanding what rate of change means in the context of a situation. And so we're going to look at example 1. And in example 1, we see that in 2017, 34,921 first-time college students applied to a state university. In 2012, 24,136 students applied. Find the rate of change in the number of first-time college students applying for admission from 2012 to 2017. And so with this problem, we need to first understand what are the two variables of this problem. And so our first variable is that the x is going to be the years, because that is our independent variable. And anytime we're dealing with years, that will always be our x. The y then is the number of students applying in those years. And so we need to remember our slope formula and go back to 7th and 8th grade math. Slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so we'll use that formula to then substitute our values in. And so we need to pick out which is our y2 and our y1 and our x2 and x1. And typically when we're dealing with years, we want our x1 to be the first year in the sequence. So in this case, we're going from 2012 to 2017. So our 2012 value will be our x sub 1 and our 2017 value will be our x sub 2. And the y's will follow in conjunction with that. So this would be our y sub 1 and this is our y sub 2. And so we look at where these plugged in. So we have 34,921 minus the 24,136 over 2017 minus 2012. And so when we simplify this fraction, subtracting both our numerator and denominator, we'll get the following. We get that m is equal to 10,785 over 5. And dividing that, we get 2,157. And so what does that 2157 mean in this problem? It means that there was an increase of 2,157 students applying to this college over those 5 years. And one of the things that you're going to know about me is that word problems require word answers. So our word answer here is what you see here, that there was an increase of 2,157 students from 2012 to 2017. Looking at example B here, we're going to do the same thing. This one's been given to us in a table, and so you can choose your x's and y's to fit however you need. And so in this one, all the values are positive, so we're not going to worry about that. And so choose the smallest values for your x's and y's. And so we're going to look at our values here. This will be our x sub 1, and this will be our x sub 2. Meaning this is our y sub 1 and our y sub 2. And so let's look at what the formula is. So we'll again use our slope formula of m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And plotting in what we've picked out, we'll have 9 minus 6 over 3 minus 2. Make sure again that your y's are in the numerator, your x's in the denominator, and everything lines up. The 9 and the 3 have to line up together. The 6 and the 2 line up together because that's the order pair that we would get from these points. And so simplifying this, we'll see that we get 9 minus 6 is 3, and 3 minus 2 is 1, and so we get 3 over 1, or just 3. And so what does that mean to our problem? That means that the distance, because that's our y, increases at a rate of 3 feet per minute. And so of our 4 options, that is option B. Okay? All right, let's look at example 2 on average rate of change. Example A here, referring to the graph below, which shows the data of the fastest growing shoe store chain in the United States between 2011 and 2016. Find the rate of change for these stores between 2011 and 2016. And so again, we'll have to find those points on the graph. And so when we're looking at the graph, we're looking at this point because these are years since 2010. So 6 years from 2010 is 2016. So it's this point here. And in 2011, we're down here. Now, could I find the rate of change for any time period on this graph? Sure. Is it going to be the same value for each of these segments? No, because look at this. Is this a straight line? No. And so this rate of change will be different than the rate of change of the entire thing or any segment in between or from 2011 to 2015. All those rates of changes will be different. Now again, they could be the same technically because it could have the same rate of change over 2 years, but the likelihood is it's not. So let's look at what we need to do for this problem. First, we need to get the ordered pairs of our 2 points. And so let's see what those are. So our point at 6 years, so 2016 is at 6, 34,000. Again, we can look across to see where it's at. Remember, this is 34 and it says in thousands. And then our other point is 1 year, so that's 2011, and then it is at 7,000. And so we'll plug this into our slope formula and get our rate of change for these years. So let's look at that. So plugging this in, we get our y2 minus y1, and so again, we'll use our first value as our 1, so this will be x sub 1 and y sub 1 down here. This will be our x sub 2 and y sub 2. Plugging into the formula gives us this, 34,000 minus 7,000 over 6 minus 1. And so we'll reduce that and get our rate of change for those years. So we get 27,000 divided by 5. We do that, we get 5,400. And so the increase in stores from 2011 to 2016 was 5,400 stores per year. Remember, we've reduced this down to just 1 year interval, even though we're talking about the rate over 5 years. Okay, so let's move on to example B. As we look at example B, it asks us to refer to the graph, find the average rate of change of the percent of households with computers in the US from 2000 to 2004. And so I've labeled out here the 2 points. And so our first one is at 0, 61. So 61% of households in the year 2000 had computers. And in 2004, because we see this is years since 2000, 2004 had 74% of computer usage. And these are approximate because, again, we don't have the exact data values. We're looking at the table and making an estimate. And so we're going to, again, plug this in. And again, I would recommend using the x sub 1 as the smaller year value. So that'll be our 0. And our y sub 1 will be the 61. And this will be our x sub 2 and y sub 2. And so we'll plug that into the slope formula. So as we plug it in, y sub 2 is 74 minus the 61 for y sub 1, 4 minus 0 for the denominator. And so 74 minus 61 is 13 over 4 because 4 minus 0. And so that'll give us 3.25. And so what that means for this problem is that the percentage of households with computers increased 3.25% per year from 2000 to 2004. And so our correct answer here is C. Now, some of you might be wanting to choose A here, but go back to what we are comparing here. We are comparing the percentage of households over years. And so we've got to keep that ratio, percent over years. Okay? And so let's continue on as we look at the slope of a line. So remember, the slope of a line is the ratio of change in the y-coordinates to the change in the x-coordinates. And so this is the formula that we've been working with all along. But I want you to pay attention to this notation here, this little triangles with y's and x's. What that triangle actually means, the triangle is the Greek letter delta, and it means the change of. And so when we read this, it's that the slope is the change of y over the change of x. And it means the same things as we look at with our original formula, y sub 2 minus y sub 1. It's the difference of the y's, right? And so difference or change of is that delta symbol. And so we look at example A for example 3, find the slope of the line that passes through -1, 4 and 1, -2. Now, we've done enough examples here, so I'd like you to pause the video here and try example A and B, the one below it here, and try those 2 examples, and then unpause, and we'll look at the solutions. All right, so let's see how you did on example 3A and 3B. So on example 3A, you're going to see that we have -1, 4 and 1, -2. Again, we want to write these out as our x sub 1 and x sub 2. So x sub, you have to get Peter to cooperate, x sub 1, y sub 1, x sub 2, y sub 2, and we'll plug that into our slope formula. So getting that -4 over 1 minus negative 1, and just putting the parentheses here to see that we do have a double negative there. And so remember, the double negative will become a plus. It becomes a plus. There we go. And so that's going to give us negative 6 for the numerator divided by 2, and negative 6 divided by 2 is negative 3. So if you got negative 3 for that, great. If not, go back, look at the steps here, and make sure you're doing your signs correctly. That's going to be the biggest mistake there. As we look at example B, we're going to find the slope of the line that passes through 9, negative 3, and 2, 7. Again, I hope that you've already tried this problem. If you haven't, pause here and try this one again, and then we'll look at it. And so we're going to plug this into our slope formula. So again, we're going to label these out. X1 and Y1. Trying to get my pen to work. So X1, Y1, X2, Y2. And so we're going to plug that into our slope formula and simplify it from. And so we get 7 minus negative 3 over 2 minus 9. Remember, we got a double negative again here, so this is going to become a plus there and a plus there. The denominator will not have it happen. And so 7 plus 3 is 10, and 2 minus 9 is negative 7. And so as we simplify that, we're going to have that negative in the denominator, but we can also move that negative to the numerator, or we can move it out front. All three of these are technically acceptable answers. We just normally don't want to leave this negative in the denominator. It's not good mathematical practice, but otherwise it's not a wrong answer to have it there. All right, so let's look at example 4. And so find the slope using a graph. So this is going to be like what we did in the first two examples. Get your order pairs, label them x1, y1, x2, y2, find your slope, and finish this off. And so again, there are two examples here, example A and example B. If you scroll down, and B does have multiple choice for you. So try these two examples, pause the video now, and then come back and see if you've gotten it right. So I've labeled the two order pairs in our problem here. We got 2, 2, and negative 2, 0. And so we'll label those are x1, y1, and x2, y2. And so x sub 1, y sub 1, x sub 2, y sub 2. And we'll plug those in. And so the y sub 2 is 2. The y sub 1 is 0. The x sub 2 is 2. And the x sub 1 is negative 2. So again, putting those parentheses there for the double negative. Now, when we simplify that, 2 minus 0 is 2, and 2 minus negative 2, so that's a plus when we do that. So 2 plus 2 is 4, and 2 over 4 reduces to 1/2. So again, if you didn't get that right, make sure you're plugging things in the right spots and make sure you're paying attention to your signs. Those are the two biggest issues for this problem. All right, let's look at example B. So again, we are going to plot these points, and so we'll see what those are. And so we've got our 2 points here. The first one is at 2, and our second one is at 2, 0. And so with those points, we're going to plug those in. This will be our x sub 1 and y sub 1. And I'm sorry about my pen, it's glitching on me. X sub 2 and y sub 2. And so from there, we're going to plug those in. So our y sub 2 is 0. Our y sub 1 is 2. X sub 2 is 2, and x sub 1 is negative 7. So 0 minus 2 is negative 2, and 2, again, this will become, double negative will become positive, so 2 plus 7 is 9. And so we get that our final answer is that the slope is negative 2/9, meaning that our final answer is A in this problem. If you get 9 over negative 2 and get negative 4/2, which is answer choice D, then the likelihood is that you flipped your X's and your Y's. Any of the other solutions are going to be interesting to come out with for that B or C option. So that's it for today. If you got any questions, make sure you put them into your Google form, and I will catch y'all next time.